are not distributable. That is not a distributive situation. SIN by itself means nothing. I mean, it has to have an angle attached to it. So, you're not going to say sine x sine pi over 2. That would be as wrong as you could possibly be. However, there is a way to expand this using your sheet. Tell me how I handle the sine of an angle minus an angle. Come on, it's right there in front of you.
Sine U.
So sine of the first,
Cosine V.
cosine of the second,
Minus cosine.
cosine of the first, sine of the second. That's exactly right. So you can't just distribute. You have to use your formula. Anytime you have an angle plus an angle plus an angle, we're going to find out in the next section, 2 times an angle, half an angle. You always have a formula for it. All right, now tell me about pi over 2. What's pi over 2? 90. So 90 on my unit circle is right here, right? This is pi over 2, right? 90 right there. So tell me about the cosine of pi over 2. 0. So this is sine x times 0 minus cosine x times, what's the sine of 90? 1? Well, what happens? Anything times 0 is 0. So you have 0 minus cosine, which is negative cosine, isn't it? And that's what we were trying to end up with. Got it?
Yeah.
This one is going to be about the same thing. Okay. A little bit tougher over here. You'll see why in a second. First of all, do I have a formula for this on my paper? No. But I do have a formula for the tangent. And what do I know about the cotangent? It is the reciprocal of the tangent. So I wonder if I could do my tangent formula upside down. Does that make sense to you?
Yeah.
Flip the tangent formula. Okay, well let's look at what would that look like if I did that. On the bottom it's going to be tan. Oh, wait a minute. Tan pi over 2. Make sure I'm doing my formula right. Tan pi over 2 minus tan u. And on the top it's going to be 1 plus tan pi over 2 tan u. Did I do my formula right? I turned it upside down.
Yeah.
Because my problem isn't a tangent problem, it's a cotangent problem. Now there is nothing wrong with that. That is absolutely a fine way of doing the problem. But there's an issue with this particular problem because of this. What did you say pi over 2 was? 90. What is the tangent of 90? Look back up here. It's not a thing. It's 1 over 0. It's undefined. So you cannot do the problem this way. If it were a different angle, it would be fine. But because it happens to be pi over 2, that isn't going to work. There is no tangent of pi over 2. It's undefined, so you can't use that in an equation or formula. So what do you think? What else could I do with cotangent? Exactly. Think of it as cosine over sine. Now, you're probably not liking that a whole lot because that means now I need 2 formulas. I need my cosine formula and my sine formula. But at least I can do that. This I couldn't even do. All right, so what's my cosine formula say? This is of a difference. So cosine first cosine second plus sine first, sine second. Now, nobody's saying anything, you're all dutifully copying this down, I'm up here blabbing away. Are you looking at your sheet and seeing this formula?
Yeah.
So you're following what I'm doing? Alright, so then my denominator is a sine of a minus, so it's sine first, cosine second, minus cosine first, sine second. Please do not cancel anything. As soon as you put these adds and subtracts in there, all bets are off, no canceling can happen. But what can we do? I'm giving you a hint. Can we plug numbers in for those?
Yeah.
So what's cosine pi over 2? So I'm just going to go ahead and mark this off. Are you okay with that? I'm not canceling it, but since it's timesing by 0, it's gone.
Yeah.
Got that?
Yeah.
What's this?
1.
So my numerator just boils down to sine u, because that's 1.
Yeah.
All right, what about my denominator? Well,
That is 1.
yeah, so 1 cosine down there. And then what happens here? Yeah. Now, I'm not canceling these out. Please understand, this is 0. So it's disappearing. What am I left with? Sine over cosine, which is tangent. Everybody okay with that? If this angle had been something besides 90, I could have done the tangent thing. I can always do cosines and sines though, so if you'd rather not even mess with the tangent, you can always do sine and cosine. All right, one more. Letter C, go ahead and get it started. See if you can start expanding these things. Nothing's canceling, nothing's distributing. You're using your formulas. You're using your identities. So you're going to use an identity here, right off your sheet, and you're going to use one here, and then you're going to add them together and see what happens. Peter, pencil on paper. I know this isn't your favorite thing, but anyway. Not like that for kids though. Is it working out for you? Yep, because what happens when you expand this one, it's going to get too big for me here. When you expand that one, you end up with sine, cosine, minus cosine, sine. So sine x, cosine y, minus cosine x, sine y. This, all of this is this. Then plus, now this one, sine x, cosine y, plus cosine x, sine y. And as soon as you do that, you should notice something. Isn't this one, or aren't, I should say, aren't that one and this one the same thing? And one's positive and one's negative, so they are gone. And then look at these other two. What do you notice about them? Aren't they also the same thing? So when you have one of them and one of them, you add them together and you get two of them. Okay, we all right with that? All right, I know a lot of you turned your homework in, thank you for that, but can anybody think of a homework problem? We have a couple minutes. Then we gotta do something else, I've got another handout for you here, but I can do a couple homework problems. Was there anything, Drew?
Number 2 and 5-2.
5-2, number 2. Now remember, if you gave it your best shot, even if it didn't end up the way it was supposed to, you're gonna get full credit. But for your own purposes, here is the situation. We have secant squared minus 1 over sine, and that has to equal sine over 1 minus sine squared. Now, you, again, you get to do the problem however you want to. One option would be to recognize that 1 plus tangent squared is secant squared. That's on your sheet. And what does that mean about secant squared minus 1 then? Secant squared minus 1 is tangent squared. So that one option would be to recognize that. Because I have all of those things memorized, they're floating around in my head, so when I see this, I immediately think about that identity. All right, so now I've used it. Tangent squared is sine squared over cosine squared. Would you agree with that? And that is divided by sine. This says sine squared over cosine squared divided by sine, which means it's multiplied by 1 over sine. Keep change book. This is a multiplication, so this can cancel. So I am left with sine over cosine squared. What do we know about cosine squared? It's 1 minus sine squared. So don't I have what I want? Sine over 1 minus sine squared. Follow all that?
Yeah.
Drew, did you follow all that?
Yeah.
All right, I can do one more, and I got a handout for you. Was there one more on the homework that you remember? I know most of you turned it in, which is great. But was there one more maybe that was bothering you? All right then, let me hand out what I have to hand out. This is some review stuff.
You already gave us, you know,
On top here is an old quiz that I gave. All right? The quiz that you have on Friday will look like this with one exception. There's going to be one more problem on it that's not one type of problem that's not here. So I want to do that problem with you right now, and then part of your e-learning will be me going through the rest of this, and you working through it with me too, okay? So I want to do one more, we've already done a couple today, but I want to do one more problem like will be on the quiz, but it isn't on this quiz. I'm adding another problem, and it is one of these solved problems. Would it be more beneficial to do it in radians or degrees? I'll do it in both. All right, so we'll do it in both. On your quiz, you'll do one or the other, okay? Whatever I say, but we'll do it both here. And you're gonna have to solve an equation, and it's gonna look something like this. It'll be no calculator. So 2 cosine squared minus 1 equals 0. All right, here we go. Here we go. We're gonna solve this equation. We've already done a couple today. We did a couple yesterday. This is just another one. All right, so what do you want to do first?
Move the 1 and divide by 2.
Move the 1 and divide by 2. So is everybody okay going straight to this? Then what?
Square root it.
Square root it. Remembering that when you square root it, it has to be plus or minus. And the square root of 1 is 1, and the square root of 2 is the square root of 2. And I will leave it like that because these are numbers I recognize, right?
Yeah.
If you rationalize it, you're gonna get root 2 over 2, which are numbers you don't recognize in terms of a triangle. So here's my triangle. My job is to find x. So x is an angle. I need to know where that angle is, if its cosine is positive or negative. Everywhere. So all 4 quadrants. And the cosine, which is adjacent over hypotenuse, is 1 over root 2. I hear everybody saying 45, so the angle is 45. Now, if I am in degrees, if these are the directions, then you're gonna stick with 45, and you're gonna have a 45-degree angle in every quadrant. Okay? So the first quadrant obviously is 45, all right? What about the second quadrant? 180 minus 45? So 135. And then the third quadrant, 180 plus 45, 225. And then all the way around to the fourth quadrant is 360 minus 45, 315. So if we're in degrees, there will be the 4 answers to the problem, right? Now, what if we're in radians? Absolutely nothing changes here. Everything's the same, except we don't think of these as 45s. We think of them as pi over 4. 60 is a third of 180. 30 is a sixth of 180. And 45 is a fourth of 180. So now all of your angles are pi over 4s. So the first one is still pi over 4. Okay, but what about quadrant 2 now? What about this guy right here? 3 pi over 4, which is 1 minus a fourth, 3/4. And then in the third quadrant, it will be 5 pi over 4. That's 1 plus a fourth. And then the last fourth quadrant there is 7 pi over 4, which is 2 minus a fourth. All right, so I want you to go back and look at, we just did this one, we did a couple yesterday, we did a couple earlier today, and make sure you can do solving those equations, because one of those will be on the quiz. All right, one solving equation. And then everything else on the quiz is on this top page here, front and back. Okay? That thing that's a bonus probably won't be a bonus, probably be a required question, so we'll go through that tomorrow. Yeah. Okay, everybody good? You know what the expectation is for tomorrow? we have expectation.